I would like everyone's attention because we want to take a close look at question 6 before we finish class today.
Yeah.
Okay, are you ready? Okay, here we have an example of a curve z minus y to the fourth equals 0 in the yz plane, and we're going to rotate this around the z-axis. Okay? Now, eventually we want to be able to write an equation in 3 dimensions for x, y, and z for the curve that we generate. Okay? Why is this one a little more difficult to do than the ones we've been doing previously in terms of writing the equation? Why is this a little tougher? Because how was it we were writing the equations before? Maybe I should revisit that. What were we thinking about here when we were writing the equation for this? Jack, what were you thinking about?
Were you looking just at the traces?
At the traces of the cross sections, right? Okay, and we knew we were getting some circles and parabolas there. So what makes this one tougher to do that with? Sophie?
It's not exactly a parabola because it's flatter at the bottom since it's y to the fourth and not y squared.
It's not only not exactly a parabola.
It's not
Malu,
a parabola. It's like a U shape.
It's like a U shape, right, but not a parabola, definitely not. Okay. So we have another situation here. We've got to come up with maybe an alternate strategy for writing our equation for the surface that we're going to generate. Okay? Can someone explain to us the thinking that you went through in question 6 in order to justify what the equation was? What was it what was the strategy that was developed here to get this equation? Anybody else here? Men?
Because you're rotating around the line.
Speak louder, men.
Because you're rotating the shape around the line, for any given point, it will make like a circle around that line.
Uh-huh.
Which is why x squared equals r squared around the z.
Okay. Because as we talked about earlier, what's true about any rotation? When you rotate a point around something, what happens? What happens when you rotate a point around something, Sophie?
Distance is preserved.
Distance is preserved. Okay, so we're going to get that circle. Okay? Okay. And it says here where r is a function of z. Why is that true? Why is r a function of z? Ian?
Because the absolute value of y is equal to r, and the original equation is z equals y to the fourth.
Okay,
So you
z.
can substitute in r for z.
Okay, so let's slow down, but you're good. Okay, I want to hear this from you. So start over again, Ian. So
Okay, so z equals y to the fourth.
okay. That's the same as this equation.
Yep. We showed that the absolute value of y equals r.
Why does the absolute value of y equal the radius?
Because on one of the traces, you can see that the distance from the z-axis to the bowl shape.
Okay, so it's more of a bowl shape like
Yep.
this, right?
The distance from
The distance from what?
the z-axis to the edge of the bowl shape
Is what?
is equal to the y distance.
Oh, it's the y coordinate, isn't it? Okay. Why do we have to say absolute value of y is r? Ian?
So it can be on either side of the z-axis.
Okay, so it can be it could be a negative y coordinate. Okay. All right, so we know the absolute value of y is r. So where do we go from there, Ian?
So then we can substitute in r for y
R
And
for
say-
what?
and say
Here?
that z equals r to the fourth.
Oh, z equals r to the fourth. Okay. All right. Where can we go from there to help us get our equation? Kate?
R to the fourth is the same as r squared squared.
R squared squared.
Yeah.
Okay.
And since r squared equals x squared plus y squared, you
Oh.
can square x squared plus y squared.
And up here we have r squared equals x squared plus y squared. So what does that mean about z? If z is r squared squared, Kate, it also has to be what?
X squared plus y squared squared.
X squared plus y squared what?
Squared.
Squared. And we have our equation for this surface. X squared plus y squared squared. Okay? Did anyone think about this differently? Alex?
Well, no, just if this equals x squared plus y squared squared, it's not the same as x to the fourth plus x squared, 2x squared y squared plus y to the fourth.
Yes, I could multiply it out, okay? And I think back here in this group, Katie, you did that, right? You multiplied it out. Okay, because it's x squared plus y squared times itself. And you could write it in that form if you want to. So x squared plus 2x squared y squared plus y squared. Okay, it would be equivalent. That would be another way to write it. But it's okay if you leave it in the first form too. Okay, so basically what is our strategy here in general? To do what, Chris?
Try to take the traces and then put things together in a way that it's a circle.
Okay.
You're rotating it around the axis.
Okay. All right, good. Okay. See you tomorrow.